Moving on to design for assembly. Again, the basics here are ease of assembly. If you've got small, flexible or sharp objects, it's going to take longer for the assembly person to pick them up and to put them into place. You need to check the orientation of your parts, that it's very clear which way they're orientated, so you're not spending each time across the course of 10,000 products looking at it in a fine way to make sure which way it goes. Where you can, make it symmetrical. Have a look at the tools that are available at the assembly provider. If there are particular ways that you can modify your design to already use the tools that they have, you can be saving your operational setup costs down the track. To minimise the amount of fixtures, minimise the number of parts. Nesting is also a really big issue. If you imagine that you have a whole bunch of these springs in a box, and imagine that it actually had a loose hook end at the bottom here, the operator would have to go and try and get these out of the box. They'd nest together, the hooks would catch on each other, it can get quite fiddly. By doing some simple things such as closing the loop at the end of the spring, suddenly you're cutting your time to assemble down quite considerably. The design on this lamp is actually quite fantastic, the way that they combine a couple of the functions and holding particular joints together with fasteners that also hold the springs on through just pulling it into place. Also, there's another angle to it where you can change the design so it clips in under, again, easy assembly for a small design change. Instead of hooking through a hole, it clips under the hole. Other things to consider, is it easy to handle with a single hand, and is it easy to insert? In terms of the lamp has 24 components. Let's say it has 3 sub-assembly, and the springs take 8 seconds each to assemble. Again, we're brought back to this example where this one here ends up taking nearly, it's less than half, nearly a third of the time that this one here takes to assemble, because of the complications of assembling springs and the linkages and everything associated with it. So again, that brings your product cost down and your assembly cost down, but you are compromising the quality of the product. In terms of cost and assembly, engage your suppliers early. Again, look at the standardised processes, tools and bulk fixtures they use. If they're already using particular types and sizes of nuts and screws, they'll be getting bulk discounts on these orders, and you can tie in with that rather than ordering smaller batches of things that will cost you a higher price. Again, each of these little price differences stack up quite considerably. In this example on the lamp, something that saves on assembly time is putting a knurled edge on the end of the screw, so that instead of needing to use a tool to tighten it, it can be done by hand. Another part with the assembly process, it's a really good idea where possible to produce your own batches and write your own assembly instructions to check how you've designed this product. Does it work and assemble the way that you expected it to? At the design technology consultancy where I worked on medical instrumentation, we used to do batches of 5, 10, even up to 20 products on site, getting all the goods in and assembling it ourselves to check the ease of access in the assembly, see any areas which were a lot more difficult to assemble than what we could see in the CAD, and also gives you the opportunity to look at variances across batches and how those tolerances might stack up and affect your product.